Hw2 Question 2. In this question, students, you'll notice that there are red numbers. The red numbers are randomized from one student to another, so that not everyone is going to be working on the exact same problem. On my screen that you can see here, I'll have a particular set of red numbers. They may, just by coincidence, match your red numbers, but not necessarily. Nevertheless, the steps that we use to tackle the problems that we see on this screen will be the same as the steps that you would use to answer the questions on your screen. So in this one, they're asking how many significant figures are in each of the following. You just need to know the rules for significant figures. The tricky part about significant figures is that sometimes zeros are counted as significant and sometimes they're not. So in question A, we have 700. We have to assume that the zeros that follow the 7, which are called placeholder zeros, are not significant. Now, there's some ambiguity there, because if I intended one of the zeros or even both of the zeros to be significant, I would also write the number 700. So there is some ambiguity there. But if nothing is indicated besides a 7 and 2 zeros, you have to assume that the zeros are not significant. We call them placeholders, and thus there is only one significant figure in that problem. The next one, part B, 1.0 times 10 to the second. The exponent times 10 to the, and whatever the exponent is, does not affect the significant figure count. What we're looking at is the 1.0. And since there's a 0 at the end of the number and to the right of the decimal point, that is a significant 0. And of course the 1 would be significant since it's a non-zero digit. So in this number we have two significant figures. Below it, part C, 1.00 times 10 to the third, the 1 and the 2 zeros that appear to the right of the decimal are significant, and so we've got 3 significant figures. Part D is very interesting. There is the number 100, and then they put a decimal point at the end of it. The decimal point is an indication that the zeros that follow the 1 are significant. So unlike in part A, where it just said 700 and there's no decimal point, in part D there is a decimal point, and that's a scientist's way of indicating that those zeros are significant. So I would say, okay, the 1 is significant and then both of the zeros are significant. Now you can always avoid the ambiguity of zeros that follow a non-zero digit but are still to the left of a decimal point by writing something in scientific notation. So for instance, in part A, if I wanted to write 700, I could write it as 7 times 10 to the second. And it would be perfectly clear to anyone that that is meant to be one significant figure. Numerically, I can write the same number by putting 7.0 times 10 to the second. It's still 700, but I would then be indicating that one of the zeros is significant and the other one is not. Or I could even be writing part A as 7.00 times 10 to the second, in which case I'd be indicating 3 significant figures. In all cases, numerically, it's 700. Scientists are encouraged to write in scientific notation in order to clearly state the number of significant figures. Part E, 0.0048. In this case, the zeros that precede the non-zero digits but are still to the right of the decimal point are not significant. If I were to write 0.0048 in scientific notation, I would be writing it as 4.8 times 10 to the minus third. 4.8, of course, is 2 significant figures. So, 2 significant figures for part E. Part F, 4.00480. That tells you that you've got 3 significant figures. If I were to write this in scientific notation, I'd say 4.80 times 10 to the minus third, which the 0 that follows the 8 and is to the right of the decimal point is significant. The zeros that precede the 4 are not. And similarly, in part G, 3 significant figures. It's actually the exact same number as part F, but written in scientific notation. And then part H, 4.800, we've got 4 significant figures because those zeros that follow the 8 are at the end of the number and they're to the right of the decimal point.